Okay, ladies and gentlemen, one of the things you need to understand about factoring for the sake of factoring is kind of pointless. So I want to start showing you some of the basics as to how factoring ties in with equations. So for example, if I ask you to solve the equation ax plus bx equals c, and I say solve it for x, the problem the way this equation is written, I can't have x appearing twice, because if x appears twice and I'm asked to solve for it, it's not going to work. When I say solve for something, I want it to appear one time in my answer. But notice what we can do. Ax plus bx can be rewritten by factoring out an x. When I take out an x, in parens I have a plus b. That is equal to c. This is now x times a plus b, quantity. We divide both sides by the quantity a plus b, which gives me the answer x equals c over a plus b. Factoring here helped us solve that equation. Next equation, solve for y. Alright, ay minus de equals by. Alright, now, when I teach in class, what I tell my students is, when you're solving for a variable, all of the terms that contain that variable have to be together. And since we live on the Florida-Georgia border, basically, what I tell them is, you got to bring the variable you're trying to solve for to one state, and you've got to put the other junk in the other state. So in this case, I'm going to call the left side Florida, the right side Georgia. The y's are in Georgia right now. The by is, if I've got a couple different ways I can approach it. I can either pull the by over to the left and move the opposite of de, or I can pull the ay over. You have to come up with a game plan. So here's the game plan that we're going to agree upon. I'm going to bring my variables that I want to solve for to the left, that's Florida, and everything else gets tossed over to Georgia. So ay stays where it is, by comes over as the opposite, or a negative by, and the negative de goes over to Georgia. So we now have ay minus by equals de. We're solving for y. Factor out a y. In parens we have a minus b, and that's equal to de. And to finish, we divide. Because we're undoing multiplication, we divide both sides by a minus b. So our final answer, y equals de over a minus b. Alright, two more examples. These are not expressions, these are equations. Solve the equation ABC equals 0. ABC equals 0. ABC basically tells me I have three things multiplied together to get the answer 0. Well, if I just told you, close your eyes, multiply three numbers together, and you get the answer 0, what would you be able to tell me about one of those numbers? And hopefully your answer is, at least one of those numbers is 0, maybe more. So the best way to say it would be either A equals 0, or B equals 0, or C equals 0. And the part that we don't talk about is, or maybe all three, but I don't care about that. I care about the word or in the middle here, because it could be, or means in math, one or the other, or both. Or in this case, or all three. So those are my answers to that equation. My next equation, 4x times the quantity 3x minus 7 equals 0. I have two things multiplied together here equaling 0. 4x is one factor, 3x minus 7 is the other. If two things multiply together to give me 0, either the first factor is 0 or the second factor is 0. So either 4x is 0 or 3x minus 7 is 0, or maybe they both are, but who cares? Or in the middle implies one or the other or both. If I solve the first case, I divide by 4. 0 divided by 4 is 0, so one of my answers is x equals 0. 3x minus 7 equals 0. I add 7 to both sides of the equation. 3x equals 7. Divide both sides by 3. X is equal to 7/3. My solution set is the ordered pair 0, 7/3. I'm not a math teacher that makes you formally write an answer set with set brackets on it, but some of your future teachers might. So it's a good habit to get into.